Hi, in this video, I'll explain and demonstrate how we do multiple regression. We're still using the same dataset that we used in the previous video, which is the elderly digital training for elderly file in Excel. So in the dataset, we have a number of variables, but this is the hypothesis that we are wishing to test. So we want to see whether digital skills of the elderly who are participating in the study have positive relationship with digital training, inspirational talks, and having digital confidence. So these three, digital training, inspirational talks, and digital confidence, are independent variables, while the digital skills are the dependent variables. So we're going to do this in three separate parts. So we're first going to do the scatter plot analysis among these variables one by one, and then we're going to do a correlation analysis for all at once, and we're going to do a multiple regression for all variables all at once. So let's start with scatter plot analysis. So from the actual dataset, I have loaded up to my SPSS. So first, I want to see digital training and digital skills in terms of their scatter plots. I'll go to Analyze Graph, Legacy Dialogs, Scatter Plot, Simple, Scatter, Define, may reset. So digital training as my predictor or independent variable to predict the outcome. The outcome is called digital skills. So independent variable is always on the x-axis, the horizontal axis. Dependent variable is always the vertical axis, the outcome that we're trying to predict. So I'm going to call this scatter plot digital training and digital skills. Continue. I can click OK or paste. I prefer to see my syntax. I click paste. So I can check and verify my variables and the procedure. Can go for run. So this result is very similar to the previous bivariate regression that I did in the previous video. So you can see here that there is a relationship, a kind of a linear relationship between digital training and digital skills. That is, people who have more digital training tend to have higher digital skills score. So when you have only some people who have received only 2 times of digital training, they receive very low digital skill score. But when you move to 3, people who have received 3 digital training, the digital skill score just improved dramatically. And those who go to 4 and 5, the increase is also pretty high. So you have that sort of relationship. Now let's look at inspirational talk and its relationship with digital skills just using the scatter plot. Let's go back. Graph, legacy, scatter plot. So I'm going to change the digital training to inspirational talk. All right, I'm going to click paste. The title here. I forgot to change. So I need to change the title. Graph, legacy dialog, scatter plot, simple. I need to change the title because this is not digital training. This is inspirational talk and digital skill. Okay, I'm going to paste. So here is correct. It's correct, consistent. Then I can run it. Now, do you observe something different here? See, the pattern is a little bit different from digital training and digital skills. So in inspirational talk and digital skills, you have seen that some people who are joining very little inspirational talk score very highly, close to 70 and slightly above 70. And some people who have joined 2 times, they even score lower than those who joined 1 time. And those who join 3 times, even lower. But some are even higher. But this relationship is still not very clear. It doesn't have a very clear lines. So that is one note that we would take, right? And then let's go for the next one, which is to look at digital confidence and digital skills in terms of the scatter plot. So actually, if I want to, I don't need to go back to the GUI. I could just copy this. It looks a bit strange. I could change it from inspirational talk. I change it to digital confidence. How does it look like? Is it one line? Okay, so there's no space. Digital confidence. Always here. So digital confidence and digital skills, digital confidence and digital skills. The color looks different, but it works. The bottom part is it works, right? Maybe when I paste it, there's a little bit of change, but the important part is the result. It gives us the good result. It gives us the result that we're looking for. So look at that, digital confidence and digital skills. When the participants or respondents have very little digital confidence, they also get a very little digital skill score. When you grow, when more people have a high digital confidence, they tend to have high skills. When they have even higher confidence, digital confidence, they get higher skill score. So you can see here, there's a kind of a trend line there that shows the linear relationship between digital confidence and the skills, which is positive, which is the higher digital confidence, the higher the digital skill score will be. So that's a quick kind of observation that I would have. Then the second part, I would do correlation analysis. Again, for all of these variables at one go. So we have 4 variables here, 1 dependent variable and 3 independent variables. Let's go to analyze, correlate, bivariate. Let's reset. So I have digital skills as my DV. So the order doesn't really matter. You can just throw everything. So you have digital skills. I have digital training, inspirational talk, and digital confidence. So these 3 are my independent variable, and digital is my dependent variable. Let's have a look at the option. I can have means and standard deviations. I just leave the style and bootstrap by default. This is also by default. The key part again, for bivariate correlation, I want my Pearson, my two-tailed test of significance, and importantly, ask SMS to flag which correlation coefficient that are significant, statistically significant by giving me the stars. I would like to go to the syntax again. So this is the correlation. So these are the variables, 1, 2, 3, 4. So I'm just going to run it. So this is the result. It tells me that for each of these variables, there are 25 respondents who fill in that particular variables, because you don't have all of them to be all equal all the time, depending on if you have missing data and what techniques or method that you use to deal with missing data, right? Some of them you may have smaller, some have higher than the others. So here we have a perfectly full respondents of, just for demonstration purposes, we have only 25 respondents, right? So you can see the score for the digital skills and digital training and inspirational talk and digital confidence, and in terms of mean or average and the standard deviation, right? But the key part of this correlation is to look at the table, and remember that we have this diagonal line, the diagonal that have correlation between the variable and itself. So we are not interested on this part. So all I would do, I would just ignore this part, and I would just focus on the one at the bottom. See, digital skills, so digital training have 0.714 relation with digital skills, right? Which is strong relationship, strong correlations, which is higher than 0.6. So this 0.7, which is 71% correlated, is quite high, and it's 2-star. It is significant at 0.001 level. So that means the significance is not by, that means that the chances of the result is by chance, or the probability that the result of this correlation is by chance is very low. It's only 0.01. So 99 point something %, this correlation is not because chance, right? And the interesting you can look at here is the other ones. Let's look at this one first. Digital confidence has a 0.811 relationship with digital skills, which is perhaps the highest. And digital confidence and digital training, 0.667. And inspirational talk and digital training is 0.6. And digital confidence and inspirational talk is 0.567. So the only one that is not statistically significant is this one. So inspirational talk actually is not statistically significantly related with digital skills. So this might be saying something later when we run our multiple regression. So this is a little bit different from the others. Well, the others are positive and significant, right? So without further ado, let's go and do our, sorry, I need to clean up my drawings so it's easy. Okay, so let's go and, so we have done scatter plot correlation. Let's go to multiple regression. So you can just follow this in a step-by-step approach. So for the multiple regression, we're going to enter all of them together. So let me show you again how to do the multiple regression. Analyze, regression, linear. So digital skills is the outcome that we want to predict, or the dependent variable. Digital training is our first independent variable. Then we have inspirational talk. So digital confidence and inspirational talk. So here we use a enter method, which means that all of these three independent variables are evaluated simultaneously. And we don't have a particular theory to say we want to test which one first. If we do that, that is a separate method, and you can choose that later. We use an enter method, and let's have a look. Model fit is very important. You need to have it there. And estimates for the regression coefficient is important. You must take there. So this is also by default. I don't need to do any plots. If I want to do plots, for example, I can sum residuals. I can do, but I don't need to do it now. I'm not interested in others. Just leave this stopping method as default, and style is also by default. Bootstrap is also by default. And that's it. I can go, okay, I'll paste, but I want to see my syntax. So I go to paste. So this is my regression. So this is my variable. 1, 2, 1, 2, 3, and dependent variable is 4. I'm going to regression, run. There you go. So this is our regression output. So we have only one model because we enter all of the independent variables at one go, right? So we have inspirational talk, confidence, digital confidence, and digital training that is used as independent variable to predict digital skills as the dependent variable. I think let me show using annotation. So this is the dependent variable. So the key part here is to look at the model summary. So again, model summary tells us how big, how much is these three independent variables can predict the variation of the dependent variable. So it says here that inspirational talk, digital confidence, and digital training can explain 77.6% of the variation of the digital skills. Or you can also reverse it and say that 77.6% of the variation in digital skills can be explained by these three independent variables: inspirational talk, digital confidence, and digital training. And then the other important table is the ANOVA table. So ANOVA table here, ANOVA here, analysis of variance, which is shortened as ANOVA, tell us to what extent that the regression fit with the data, right? Or to what extent that the regression can explain the dependent variable that we are interested in. So to do that in ANOVA, the standard is to calculate what we call the F-test. So the f-test here has a value of 24.26, which is much higher than the minimum value of 1. There's a calculation to calculate f. It's not that complicated, but you don't want to calculate this by hand, but you can if you want to. An important part is this f-test is significant at less than 0.001. And it has a degrees of freedom of 3 and 21. This will be useful later when we report the conclusion. So the key part that we are very interested in here is that the model summary, right, is significant by looking at the f score, the f-test score, and the signal value. And last, but perhaps the most important part, is to look at the contribution of each of these independent variables in predicting the dependent variable. So you can use unstandardized beta coefficient or standardized beta coefficient. Remember in regression, in bivariate, regression, you have y equals to the constant or intercept b null or b0 plus the slope of the first variable multiplied by the variable. Let's say if we just look at the relationship between digital training as the independent variable and how is that predicting digital skills as the dependent variable, that b value is the slope or the how important, which tells us how important is the contribution of this independent variable on the dependent variable. So this beta is this one, this coefficient. So this is the beta, right? So, but if you have multivariate or multiple regression, we have a slightly, very similar, but slightly more complex. So y equals to b, I'm sorry, but because I don't have a special pen, I'm using my mouse here. So pardon me. So we have the intercept where everything is 0. So that is where the regression line hits hits the y-axis, equals to the slope of the first independent variable b1 x1 plus the slope of the second independent variable b2 x2. Right? And you might have 3 variable here because here we have 3 variable. The slope of the third variable b3 x3. So x3 is the third independent variable, and it's a slope, and it's a second independent variable, and the slope, and first independent variable and the slope, and this is the y, and this is the intercept. So that's how it goes. So here what we have here is because we have 3 independent variables and they be measured rather differently or mean differently, right? So I would go for standardized coefficient beta so they are comparable. So you can see here the digital confidence is the biggest in terms of its beta than the other beta value. So you can see that you can interpret this as this: 1 unit increase in digital confidence will increase 0.7 for the digital skills, right? And it's significant at less than 0.001. And the digital training, right? It has a standardized beta of 0.44. So that means 1 unit increase in digital training will increase the digital skills by 0.444. And it's also significant. Still less than 0.05. So it's significant. And inspirational talk, which is the variable that we're quite interested in the previous scatter plot, it shows that actually it's negative. So don't you think this is a little bit counterintuitive and quite interesting, right? But it's still significant. But important part is, while these two are positive, this one is negative, this one. So what this is saying is that inspirational talk, so the more people join inspirational talk, the lower the digital skills will be. So the relationship is negative. So let's go back to the write-up, right? So we have got the results. We've got the model summary, the ANOVA, so I posted there. So we want to write up the results. So this is how you report the finding. We have conducted multiple regression to investigate whether this independent variable predict the dependent variable, and the results suggested that the model explained how many percent of the variance. So this is the 77.6, remember? 77.6 is the R square. So how much is the regression equation can explain the variation in the outcome or dependent variable, and we find that for the digital skill score as a dependent variable, it has F321. So that comes from ANOVA table F. Here F is 24, 321. So F24, 321 and significant. And we mentioned the beta coefficient. So for digital confidence, the beta is here and significant. For digital training, the beta is here and significant. And the inspiration talk is negative. So we say digital confidence and digital training contribute positively to the model, while inspirational talk contribute negatively and significantly to the model at minus 0.33. And then I would write the regression equation. But where do you get this 28.53? So you will not forget that when you look at your output here in the standard in the coefficient, beta coefficient, there's a number there, 28.537. What is that really? Why do we have that? If you remember the equation that I've shown you earlier, y equals to b null plus b1x1 b2x2 b3x3. So this is the b null, or the constant, or the intercept. Remember, it's called in here in the table, it's called constant, or in mathematics we call them intercept. So that is the value when all of your, if this is all zero, if all of your independent variable, the predictors are all zero, that is where your regression line at this value will kiss or will hit the y-axis. So y-axis is the dependent variable where you plot it, right? Remember, you plot your independent variable as your x-axis and your dependent variable as the y-axis. So even when people never receive digital training, they never have digital confidence, they never join digital inspirational talk, they will still get a score of 28.53 for digital skills. So digital skills is a test really. So they will get 28.5. So then we enter each of these beta value into the equation. So 0.44 multiplied by digital training, 0.7 multiplied by digital confidence, and minus 0.33 to the inspirational talk, which is this one. So that means if I give you a question, what is the chance for an elderly who never joined digital training is 0, but is super confident at the score of 10 for digital confidence and never joined any inspirational talk? What do we predict in terms of this elderly's digital score? That's very easy, because digital training is 0, inspirational talk is the person never joined inspirational talk, so inspirational talk is 0, multiplied by this is 0, and this person have very high confidence, so 10. So 10 multiplied by 0.7 becomes 7. So 7 plus 28. So this person's digital skill score will be around 35. So basically, that's what it means with this equation. So this equation is very useful because it helps you predict the future. Just like if you see how some businesses can be very successful because they can predict their customers' behavior and what the customers want. If you are running a large company or a large e-commerce company and you have like millions and millions of customers, you may need to do this kind of regression like many times a day, even every hour, even every minute, because you keep on predicting the behavior of your users in the website, right? So this is why regression is very useful, and I hope this is a useful session for you. You can review the material in the video if you have any questions. Thank you. Bye.